All right, let's talk about how to determine if events are independent. Now, we have done this earlier in the year, okay? And so we also know what our quality is that is needed to be independent. So let's talk through that as we develop essentially a formula that you need to know if things are independent. And what's interesting, and what's important for you to know is that this formula that you have to check is not on the formula chart. Okay. And I'll be giving you one of those formula charts here shortly, probably in the next day or two. So that's not on the formula chart. So this is one thing that you have to kind of either memorize, or we can learn to put it on the formula chart right as we get closer to the test. And so that means that's another reason why we are trying to intuitively develop how to know this formula so that it's easier to remember. Here we go. So we have this situation where you have gender and their preference of their favorite subject, English or math. So we have our data here. Now, we've talked about this, how to determine if two variables are independent. How's gender and your subject preference independent? Specifically, in this case, we're going to independent is female and preferring English are independent of each other. So what does that mean if female and preferring English as your favorite subject are independent? Well, hopefully, we've done this enough where we know, well, the fact that you are one thing does not change the rate. So the fact that you are female does not affect the rate at which you prefer English. Okay. So there is, so the females are preferring the English at the same rate as the overall. Remember when we did conditional probability and we compared to the overall marginal probability? So keep that in mind as we move forward. All right, so conditionally, we wondered if the fact that you are female does or does not change the rate at which you prefer English. So with what we learned yesterday, that was this notation. Probability of, given that you are a female, at what rate do you prefer English? The fact that you are female, what rate do you prefer English? So if we then think about, okay, to check for independence, what should we compare this to see if the rate has changed? Okay, so let's think back to earlier in the year. Do you remember when we would go through that stress of, which way do we do our arrows, that kind of thing? So we said, okay, what's our explanatory variable here? And we hopefully know gender is. Okay, so do you remember that then this was the way that we would do our fractions? And so these would be our denominators. So out of the females, so that would be the 180 out of the 320 prefer English. So the fact that you are female, 180 out of those 320 prefer English. And we would compare that to the marginal, the overall rate at which you did what? Was it the overall rate of preferring English, or was it the overall rate of being a female? Okay, 320 over 600 or 330 over 600. So what was the overall that we should compare it to? Overall preferring English or overall being a female? So hopefully it makes sense to you that we want to compare that to the overall rate at which you prefer English. So that's why we were comparing this conditional probability to this marginal probability. All right, and remember, if those were within 1% of each other, then we said they were independent. So let's take a look. Here is our overall prefer English rate, 330 over 600. Here is given that you're a female preferring English. So there's that. So that's what I should compare. I mean, technically, this part isn't really needed, okay? But let's look at what I should be comparing to each other. Is the fact that you are female affecting the rate at which you prefer English? Remember, it has to be within 1 percentage point, and it's a little bit higher than that. It's more than 1 percentage point away. So, yes, the fact that you are female is affecting the rate at which you prefer English. So I know if you are female, you are more likely to prefer English than that overall English preference. Okay? So that's when we said not independent. The fact that you are female makes it slightly more likely that you prefer English as your favorite subject. And then I listed those specific numbers. Okay. So from this, we're going to develop really kind of like a generic formula. And it comes naturally straight from, well, here we go. Let's talk about this first, I guess. So the next question then is, if the events are independent, so I'm going to cover that up here at first. In fact, I'm going to go ahead and cover that up here. So if they are independent, then what are these numbers inside here? Okay, so what are those numbers if they are indeed independent? Well, what does that mean if they're independent? That means that they should be preferring English at the same rate. So I want to see, hey, what is that overall English preference? Well, we already know that overall English preference was 55%. So if that overall English preference is 55%, then what proportion of the females should be preferring English? And what proportion of the males should be preferring English? If the fact that you are male or female doesn't affect and you prefer it at the same rate of 55%, then you're just going to take 55% of your 320, and that's at 176. So that's what should go here. And then that 55% of your 280 males is 154. So that's what would be happening if the fact that you are male or female is not affecting the rate. So everything is 55% of the total. All right, so here we go. Now let's put in some numbers. And I think I'm going to come over here and kind of have a blank page here. Okay, so let's see how we can do this. Let's think about it. If given that B has happened, remember this is our given that B has happened, the probability of event A. That's like when we said, given that you're a female, what's the probability of you preferring English? So here's my question. What letter should go, what event, A or B, goes in there? What is the overall that I compare it to? Was it A or was it B? So hopefully you can see that we were comparing, if this is A and this is B, we were comparing it to the overall rate of A. So that is what goes here. So this is the development of that independence formula. We are seeing if, and actually I like to say this second thing first, is the fact that B has happened, is that changing the probability of A? So then what we know is if this equals this, then the fact that B has happened has not changed the rate, and they are then independent. That's it. That's the key. So, one thing to keep in mind, and this is why at this point I wish I had given you the formula chart, but it's okay. I'll bring it back out whenever will revisit it whenever I do give those to you. So this here, that is on the formula chart. Okay. So what's going to end up happening is when we do get our formula chart, one of the things that we're going to write on there is we'll add to that independence. And so we'll add on there because there's some things that we need to know that it doesn't include. And one of them is this. In order to be independent, then this has to be the same. Okay, very good. Here is just a then generic way of thinking of things. Here we have, so here's kind of a summary of the all probability up until now. Okay, so this is a good way to kind of just summarize everything we've done. And this is really a good stopping point. And we're just going to practice everything till now, up until now for today and then tomorrow. And then we will then quiz the probability on Friday. So here we go. If you have the A or the B, then first, are they disjoint? Because if they are two separate circles, then if you want to find the probability of A or B, then you could just add those two probabilities. But if they are not, if there was some overlap, then we got to be careful when we are doing our probability, because if we added A and B, something might get double counted and we would need to subtract that double counted. Okay? So do keep also in mind that if they are disjoint, then there is no intersection. So if they are disjoint, then their intersection is 0. Okay. Now, let's do the ands. So if we have this and, that's the intersection. So then to do that, ask yourself, are these independent, or if it's conditional, is something changing? Well, if they are independent events, then easy peasy, given A and B, the probability of A and B happening is just multiplying them. Okay? But if they are conditional, then there's something else more involved. And the fact that something is happening, I wish I would have changed this. That's weird how that works there. Okay, well, I see what's going on. But the probability of A and B, I have to do, given that A is happening, then I have to multiply A, probability of event A, and probability of B, given that A has happened. Because, see, this probability might be different if A has already happened. Now, this is where I also wish I would have shown that a little different, because we kind of did the A's and B's backwards, right? Here's another way we could put this in here. A given B equals the probability of A. Okay, that's what we did right now earlier. That is what is equal to that. I just switched the A's and the B's around. Okay, and that's what's telling us if they are independent. Okay, so that is your summary for all of those. And I think that then brings us to the assignment. And so this assignment is just really practicing them all. And then we'll practice again on the rest of it tomorrow before we quiz on Friday. Okie dokie. Good luck to you.